Hello everyone, myself Shilamoni Saha and this is my ninth semester. Today I am going to present our final term presentation. We did our project on 3-bit synchronous counter and our group name is counter. Let's move into the next slide. Presentation agenda. Today we will talk about counters, type of counters, synchronous counter, simulation and hardware implementation and discussion. Let's meet our team. Simanta Saha, Shilamoni Saha, Nier Nazmus Sakib and Akramul Haque. Let's move into the next slide. Counters. A counter is a digital circuit that is used to count the number of events or occurrences for specific signals. JK flip-flops are commonly used in digital counters because of their ability to toggle their output based on the input and current state of the flip-flop. We know a basic JK flip-flop counters can be built using multiple JK flip-flops connected together in a specific configuration, and the output of one flip-flop is connected to the clock input of the next flip-flop in the chain. This creates a ripple effect where the output of each flip-flop toggles based on the state of previous flip-flops. Let's move into the next slide. Type of counters. There's two types of counters, asynchronous or ripple counter and synchronous counter. There are different types of counters based on the number of flip-flops and counting sequences. Let's move into the next slide. Asynchronous or ripple counter. In this type of counter, the output of each flip-flop is connected to the clock input of the next flip-flop. This creates a ripple effect where the output of the flip-flop toggles based on the state of the previous flip-flop. And asynchronous counters are simple and easy to implement but suffer from a timing issue where the output signals are not synchronized. We can see an example on this slide, and my next slide will be presented by Simanta Saha. Thank you.
Thank you, Shilamoni Saha, for your wonderful presentation. In your presentation, you have explained us about the counters and type of counters, and you also discuss about the asynchronous counter. With the asynchronous counters, there is some specific problems in our asynchronous counters that it suffers from a timing issue because the output signals are not synchronized and it creates a ripple effect. So we need to solve these problems. For solving this problem, we came to know that we have synchronous counter. In synchronous counter, we have all the flip-flops are triggered by a same clock signal. This ensures the output signal changes at the same time, eliminating the timing issues of asynchronous counters, and it also ensures all the flip-flops change state at the same time and eliminates any potential timing issues that could arise due to the propagation delay of signals through the flip-flops. Here we have put two flip-flops that represents we have a 2-bit counter that means we can count up to 0 to 3 means 4 digit. Here we have seen that here we have one clock signal and it is continuing. For our presentation and our project, we have decided to design a 3-bit synchronous binary counter. A 3-bit synchronous binary counter, it counts from 0 to 7 using 3 flip-flops that change state simultaneously with the same clock signal. Each flip-flop represents binary digit of the count, with the first flip-flop representing the least significant bit and the third flip-flop representing the most significant bit. Here we have 3 flip-flops and all of them are connected with the same clock signal. We can see that. And our initial count is 0, 0, 0 means 0. And our final count is 7, 1, 1, 1. and when we get 8 it will recycles. And here we can see that from the clock signal we get the signals. Let me show you our circuit diagram for the project. Here we have I have already explained that the 3-bit synchronous counter. We have also did the same thing here. There are 3 flip-flops, and we have also connected a digital display for showing the results 0, 1, 2, to 7. Let me play a video of our project. Here is our simulation video where we can see that our counter is now counting from 0 to 7 and it is repeating itself. That means we have successfully performed our experiment and it was successful. And our other teammates will explain the other things like discussions and conclusions of our project and the hardware implementation part. Thank you. That's all for me.
See the slide. So basically our group member describing this simulation part by part, and this our final part or software presentation in our project. So the next slide. So this mainly our hardware implementation, our group member implementation this project in our classroom. And in that time we also describe our hardware implementation part by part, and we also describe this project, how we can implement this project. And I hope everyone understood our software presentation. So the next slide, our discussion part, mainly the goal of the project to design implementation of 3-bit synchronous counter using JK flops. The counter was designed to count from 0 to 7 and then repeat the cycle, and was tested using a series of clock pulses. The circuit was designed using JK flip-flops, which are commonly used in counter design due to their simplicity and versatility. In this design, the 3 JK flip-flops are connected in series to from a binary counter, with the output of each flip-flop connected to the input of the next flip-flop in the chain. To ensure synchronous operation, all 3 flip-flops in the chain are triggered by the same clock signal. This means that each flip-flop change its state at the same time, eliminating any timing issue that could arise in an asynchronous design. The circuit was tested using a series of off pulses and it was found to work perfectly. The output of the counter accurately reflected the count of the number of pulses received, with the count resetting to 0 after reaching 7. So this is my race coming part and my presenting part also. So basically we are implement this software implementation, and in our classroom we can also implement our hardware implementation. Me and my group member also implement this project. So this is my presenting part. Now the last presenting part continue. Our last group member, MD Akramul Haque, now continue with this. Thank you, everyone.
And I am going to discuss about the conclusion part. In conclusion, the design and implementation of 3-bit synchronous counter using ZK flip-flops were a success. The circuit was designed to count up from 0 to 7 and then repeat the cycle. It was tested using a series of clock pulses. The output of the counter accurately reflected the count of the number of pulses received, with the counter resetting to 0 after reaching 7. Overall, this project provides valuable insights into the design and implementation of synchronous counter using ZK flip-flops. By successfully designing and testing the circuit, we are able to deepen our understanding of fundamental concepts in digital electronics and gain practical experience in circuit design and testing. Now we're gonna move next slide.
Thank you everyone for your time, and we are open to any questions and we'll be happy to answer them. And thank you for your attention. That's the presentation of our topic 3-bit asynchronous counter. Thank you.